Mean, standard deviation and variance. Here we're going to look at some statistical topics. Just imagine that you've conducted an experiment and you've got the data 1, 2, 3, 4, 5. You could be asked to find the mean, and all the mean is an average, and we represent the mean by x bar, and to find the mean we add up all our data and divide by the number of pieces of data. So the mean here would be equal to 1 plus 2 plus 3 plus 4 plus 5 divided by 5. And if you look at our data is symmetrical, so the mean is actually going to be 3. We've also got these two relatively new topics, standard deviation and variance. And what the standard deviation and variance is a description of how spread out your data is. The more spread out your data is, the larger the standard deviation and the larger the variance. In the IB, you don't really have to be able to calculate the standard deviation or variance by hand. You get to use your GDC. TA Inspire by opening a spreadsheet, typing in your numbers 1, 2, 3, 4, 5, giving your list a number, say X, go to a spare cell, menu, statistics, statistical calculations, one variable statistics, there's only one list. Our list is called X. OK. Scroll down, and there is your standard deviation, sigma X equal to 1.41421. So the standard deviation is equal to 1.41, which is actually equal to root 2. Our variance of x is equal to the standard deviation squared, which is equal to root 2 times root 2, which is 2. So for this original set of data 1, 2, 3, 4, 5, we found that our mean is equal to 3, our standard deviation is equal to root 2, and our variance, which is equal to the standard deviation squared, is 2. So a typical IB question is to then say, what would happen if a constant value of, say, 10 is added to each value of the original data set. Well, let's take a look at the new data set. Well, that would be 11, 12, 13, 14, 15. The new data set is still symmetrical around 13. So the new mean would be the old mean 3 plus the 10, which is 13. So in general, if you add a constant value to each piece of data in a set, the new mean is the old mean plus the value added to each piece of data. Another question they might ask you is, how is the variance or the standard deviation changed? Well, let's look at the data. it's still spread out in the same way. The 11 is still 2 away from 13. The 15 is still 2 away from 13. The 4 is still 1 away from the 13. So if you add a value to each piece of data in a set, the standard deviation doesn't change. So that would still be equal to root 2. If the standard deviation doesn't change, neither does the variance. So the variance would still be equal to 2. The trickier question to ask would be, what would happen if each piece of data is multiplied by 10? What would happen to the mean, standard deviation and variance? Let's have a look at our new data set. Well, that would be 10, 20, 30, 40 and 50. Again, if you look at the data set, it is symmetrical around 30. So our mean x bar would be equal to 30. And that's the rule of thumb. When multiplying each piece of data by a multiple, the mean is also multiplied by the multiple. So in this case, our old mean was 3 times 10, our multiplier, and it's equal 10 times 3 is equal to 30. Now we need to decide what happens to our standard deviation and our variance. If you look at the spread of the data now, the data is a lot more spread out. In fact, there is 10 times as much space between each piece of data. The distance between 1 and 2 is 1, but the distance between 10 and 20 is now 10. So the new standard deviation is equal to 10 times the old standard deviation, root 2, which is 10 root 2. And the variance also, so the variance of x, well, variance of x is the standard deviation squared, which is 10 root 2 squared, which is 100 times 2, which is equal to 200. Which is, if you notice, the multiplier squared times old variance. In summary, if you add a value to each member of a data set, the mean changes in exactly the same way. You just add that value to the mean, and the standard deviation and variance remains the same. If you multiply each member of a data set by a multiplier, the mean changes by multiplying the old mean by that multiplier. The standard deviation also changes by multiplying the standard deviation by the multiplier, whereas the variance changes by multiplying the old variance by the multiplier squared.